Section 4.6 is on reciprocal functions, and we're going to do this over 2 days. I guess the first thing we should do is remind you what a reciprocal is, though I suspect you remember. 2 over 3, what's the reciprocal of 2 over 3? 3 over 2, right? What's the reciprocal of 5? 1 over 5. How come? Because 5 is the same as 5 over 1. Reciprocal, you're just flipping it over, right? So what we're looking at when we look at reciprocal functions is 1 over f of x, where f of x is a function. So basically you're taking the reciprocal of f of x, and what we're going to look at today is how to graph reciprocal functions. So maybe what we'll start with is, like I always seem to, we'll start with the mother function. The mother function for reciprocal functions is y equals 1 over x. That's the simplest reciprocal function we can graph. So before we graph that, we're actually going to graph something even easier. We're going to graph y equals x. And you should be able to graph that right now, but in order to help us through this whole process, let's make a table of values. We'll set up an x and a y, and we're going to put in some values for x here. We're going to put in quite a few values. We're going to put in -10, -5, -2, -1, -1 half, -1/5, 0, and then we're going to go back up in the positive direction. So 1/5, 1/2, 1, 2, 5, 10. Boy, that's a lot of points. The good news is, since y equals x, y is the same as x, the y values are exactly the same. -10, -5, -2, -1, -1 half, -1 over 5, 0, 1 over 5, 1 over 2, 1, 2, 5, and 10. Wow, what a waste of time, eh? Anyway, if we were to graph this, let's look at a few of the points. We have -10, -10 is one point. Well, -10, -10 is down here. There's another point at -5, which is right here. -2, -2, 0, 0 is a point. I see 1, 1. I'm not going to graph them all. Anyway, you can see what's happening. You should know this anyway. Y equals x, you already knew this, is a line that goes on a 45-degree angle through the origin. So let's draw that. Okay, there we go. That's y equals x. Now what we're going to graph is what we're really interested in, and that is this. Y equals 1 over x. So what we're going to do this time is we're going to graph y again. We're going to make it fill in a table of values. We're going to ignore this, okay? Ignore this middle one. I'm going to look at what happens to these x values when we plug it in here. So we're putting -10 in here. I get 1 over -10, which is the same as -1/10. I put -5 in here. I get -1/5. I put -2 in here. I get -1 half. Okay, here's a very important point right here. If I put -1 in here, I get 1 over -1. 1 divided by -1 is -1. Okay, if I put -1 half in here, I get 1 over -1 half. That looks confusing. Basically, this is divided, right? So it's 1 divided by, let's forget the negative for now, 1 half. Make this a fraction, 1 over 1. To divide fractions, you actually flip the second one and multiply. You get 2 over 1, or just 2. That makes sense, because we're taking the reciprocal of this, which is just 2. So what would you get? Oh, -2. If you take the reciprocal of this, you're going to get -5. The reciprocal of this is 0, so what's 1 over 0? You can't do it. That's undefined. There's no value there. 1/5, if you take the reciprocal of that, you get 5. Reciprocal of 1 half is 2. Reciprocal of 1, if you put 1 and 1 there for the x, you still get 1. If you put 2 in there, you get 1 half. If you put 5 in there, you get a fifth. And you get 10 in there, you get 1/10. Okay, let's graph some of those points. So one point is -10 and -1/10. That's barely below here at all. Then -5 and -1/5. It's just a little more. -2 and -1 half. So that'd be right here. -1, -1. Oh, that's a very important point. We'll talk about that in a second. -1/2 and -2 would be here. -1/5 and -5 would be here. Interesting. Do you see what's happening? I'm going to stop there. I've still got some more points to do. But so far what's happening is it gets closer and closer and closer to this axis right here, but it never touches. And it gets closer and closer to this axis, the y-axis, and never touches it either. Shouldn't do that big droop out there. Hard to draw. Okay, let's draw some of the other points. 1/5, 5. So 1/5 and 5 would be around there. 1/2 and 2 is here. 1, 1. Oh, there's that important point. 2 1/2, 5 1/5, and 10 1/10. So we get the same sort of shape over here. Gets closer and closer and closer, but never touches that axis. And good luck to me drawing this. Gets closer and closer and closer, but never touches that axis. Not bad. That's the graph. The purple one's the graph here. Now, I want you to look at a couple very important points here. One is this point right here, and one is this point right here. Do you see whether it's y equals x or y equals 1 over x? You get the same y value here. -1 stays the same, and that's because -1 over -1 is still -1. Same when x is 1. Whether it's y equals x or y equals 1 over x, 1 over 1 is still 1, so those points stay the same. So those are two very important points that we're going to talk about more in a second. That point and that point. Those points were on the y equals x graph, and they were also on the y equals 1 over x graph. Those are the only 2 points that were on both those graphs. Those are important points we'll talk about in a second. First of all, we're going to introduce you to an amusing word, which is asymptote. And what an asymptote is an imaginary line that a graph gets closer and closer to, but it never actually crosses it or touches it. Now, we have 2 asymptotes in this graph. Can you see where they are? One asymptote is right here along the x-axis. The graphs are getting closer and closer to that line, but they're not actually touching it. The other asymptote is along the y-axis. The curves are getting closer and closer to that line, but never touch them either. So these red lines are asymptotes. This is called a horizontal asymptote. This is called a vertical asymptote. Those are just imaginary lines. They're not actually part of the graph, but they're important to recognize that the curves are getting closer and closer to these asymptotes, but never touching them. Okay, that's all the basics you need to know. Now I'm going to show you the steps to graphing a reciprocal function. The steps are as follows. Step 1, graph f of x. So rather than graphing 1 over x, we started by just graphing x, and that's your first step. Graph just f of x. Then you're going to always make the x-axis a horizontal asymptote. Now, next year we'll do reciprocal functions again, and they'll often be horizontal asymptotes that aren't the x-axis. But for this year, they'll always be the x-axis. Why is it always the x-axis? Because the form of our reciprocal functions this year are y equals 1 over something. So, in order to get a point on the x-axis, what's the y value of every single point on the x-axis? Every single point on this x-axis has a y value of 0. So we would need, in order to get a point on the x-axis, we need this amount, this 1 over something, we need it to equal 0. We want 1 over something to equal 0. What number can you put in here to make it equal 0? Nothing. Some people say, well, sure, you could put 0 in there. 1 divided by 0? Can't do it. You can't divide by 0. So this is the reason why you can't have a single point and why you end up with an asymptote of the x-axis. It's because it's impossible to do 1 over something and get a y value of 0. And you would need a y value of 0 in order for it to land on the x-axis, because every point on the x-axis has y as 0 as its y value. So maybe I'll just write here, since there is no way to get a y value of 0. Can't do it. So that's why you have the horizontal asymptote. Okay, step 3, draw a vertical asymptote at the x value, or values, it could be more than one, that makes the denominator equal to 0. In other words, you're going to look for the MPVs. So, for the one, there's actually 2 ways you could do this. We were working with y equals 1 over x. So one way you could figure out where the vertical asymptote is ask yourself, what's the MPV in this case? Well, the MPV is x cannot equal 0, because then you'd have 1 divided by 0. So that's why, in this case, you have the asymptote right here where the x value is 0. What if it wasn't y equals 1 over x? What if it was y equals 1 over 2x plus 3? Well, then you would say, for your non-permissible value, that 2x plus 3 cannot equal 0. So you subtract 3 from both sides. 2x equals -3, divide by 2, divide by 2. you get x equals negative 3 over 2, which is the same as negative 1.5. So you'd go over to negative 1.5, which is right here, and you draw your vertical asymptote right there. But I don't want to really do that because that messes up my graph. Okay? So there's two ways to get the vertical asymptote. One way is the way I just told you, so I'll label that A. And the second way you can get the vertical asymptote is just to look at wherever f of x crosses the x-axis. So f of x in this case was this black line. That black line crossed the x-axis right there, and so that's why the vertical asymptote is right there. And it kind of makes sense that that would be there because wherever f of x crosses the x-axis is where f of x is equal to 0, and then this is 1 over f of x, and you can't divide by 0. So anyway, step 4 is the points that will stay the same where y equals 1 and y equals negative 1. That's why I was showing you these highlighted points. So once you've drawn f of x, you can figure out 2 points that will also show up on 1 over f of x. And step 5, as f of x increases, 1 over f of x decreases, and vice versa. So that takes a little bit of explanation. If you look at this highlighted point right here, let's look at f of x. That's this one right here, right? This is your f of x here, this black line. As you move from this highlighted point and the values of y get bigger and bigger and bigger for f of x, what happens to the purple curve, the 1 over f of x? The points get smaller and smaller and smaller and smaller. Okay, in this part of the graph here, in f of x, the y values are getting smaller and smaller and smaller. What's happening to the 1 over f of x? The points are getting higher and higher and higher and higher. They're getting bigger and bigger. Same down here. If you look in this region here, this is where f of x is getting bigger and bigger and bigger and bigger, and at the same time 1 over f of x is getting smaller and smaller and smaller and smaller. Down here, f of x is getting smaller and smaller and smaller and smaller. At the same time 1 over f of x is getting bigger and bigger and bigger and bigger. Okay? That is what you need to recognize. So let's graph this one now. So the first step we said is we will graph f of x. So instead of graphing y equals 1 over 2x plus 5, we're going to graph y equals just 2x plus 5. That's this right here. This is what we're graphing is f of x right here. So we can do this very quickly. This is in slope-intercept form. The y-intercept is 5, and the slope is 2, or 2 over 1. So we go up 2 over 1, up 2 over 1. You could also go down 2 over 1, down 2 over 1, down 2 over 1, etc. And we can draw ourselves a line. And there we go. This is our f of x, right? This is not actually the graph we want, but we can use this graph. Okay, the next thing it says to do is to make the x-axis a horizontal asymptote. So no problem there. We can do that very quickly. We have a horizontal asymptote right here. Next thing we're going to do is we're going to make a vertical asymptote. Now there's 2 ways we said we can do this. One way is we ask ourselves, what is the non-permissible value of this? Well, the non-permissible value is when 2x plus 5 equals 0. It can equal 0, because then you'd be dividing by 0. So if we solve that, you subtract 5, you get 2x cannot equal negative 5. Divide by 2, you get x cannot equal negative 5 over 2, which is the same as negative 2.5. And if you go to negative 2.5, negative 1, negative 2, negative 2.5, hey, remember the other way I said you could find the vertical asymptote? Just look at where f of x crosses the x-intercept, and that's where it is. It crosses the x-axis, and that's where it crosses the x-axis. So you know your vertical asymptote is right there. Okay, there we go. Step 4, points will stay the same where y equals 1 and y equals negative 1. So look at f of x and ask yourself, where on this black line, which point has a y value of 1? Right there. That has a y value of 1. So that point is very important. It's going to stay the same in our new curve. And where on this black line, where is there a y value of negative 1? This point right there has a y value of negative 1. That point's also important. That's going to stay on our new curve that we're about to draw. So now we're going to draw the curve. And what we said is, as the graph gets bigger and bigger and bigger here, it's going to get lower and lower and lower here. But how low can it go? Well, it can't cross this line. Remember, it can't touch it, it can't cross it. It's going to get closer and closer to that horizontal asymptote, but never touch it. As the graph gets lower and lower in this bit, what's happening to the 1 over f of x? It's getting bigger and bigger and bigger, but it can't cross the asymptote, so it just goes up like this. I know I'm not doing it exactly accurate, but it's pretty darn close. And this is as close as you have to do it too. I'm not expecting you to nail this. You need to nail these 2 points. You need to nail where the asymptotes are. But as long as you get the general sense of this, it's totally fine. Okay, here the f of x is getting bigger and bigger and bigger, so that means the 1 over f of x will get smaller and smaller and smaller. Can't touch the asymptote. Gets closer and closer, never touches. Here f of x is getting smaller and smaller, which means 1 over f of x is going to get bigger and bigger, and you get this shape like this. If you look, you get pretty much the same sort of shape that we had here. In fact, as long as you have a line, because we're doing only linear reciprocal functions today, you're always going to get that same shape. If the line has a positive slope, it'll look like this. What if the line has a negative slope? Well, let's draw it very quickly what it would look like. Here's my coordinates. Let's draw a line. If you were to draw the asymptotes, there'd be an asymptote along the x-axis. There'd be an asymptote that goes right through here because that's where f of x touches the x-axis. You'd find your points that are on positive 1, I don't know, probably somewhere around here. You'd find your point that's at negative 1, maybe somewhere around here, and then the graph would go like this. That's not very well drawn, and like this, and it would go up like this. Whoa, that's really bad. And it would go like this, but never actually touch. So you can see you get the same sort of shape, but it's almost like a mirror then from this one. Those are the only 2 possibilities when you have a linear reciprocal function. So it's really not too bad. You can see here's another one, but this time you're doing the opposite thing. They give you what 1 over f of x is. You have to find what the function is, what the non-reciprocal function is. Okay, that sounds really difficult at first. It's actually not that bad. Which points stay exactly the same on both of them? Wherever y is equal to 1, well, that would be right here, right? That point has a y value of 1. And wherever y is equal to negative 1. So that would be this point. This point has a y value of negative 1. You're going to have the same points in the f of x as you do in the 1 over f of x. There's one other point you can figure out. See this vertical asymptote? How do we find the vertical asymptote? We had 2 ways. One was to look for the MPVs, but the other way is we said wherever the f of x crosses the x-axis. So that must also go through there. Hey look, we now have 3 points. We didn't even need 3, we only needed 2. But 3 is even better, we'll take it. So we can join these 3 together and we have our f of x. F of x is linear. We knew it was linear because all the graphs we're working on today are linear, and they all have this shape, that double kind of curve shape like that. So we put some arrows on the end of this and we are finished. This graph right here is f of x. These 2 curves here together are 1 over f of x. Okay, we're finished. Next day we'll do reciprocal functions of quadratic functions.